students, welcome back to the class. Today again we will be solving gravitation chapter. In gravitation chapter we have solved many questions from the example in the video itself. If you see those questions, it will help you. Those problem solving questions are also there. Now the questions which were not solved, that is the exercise part, I will solve it for you. Let us see one by one nicely. If you go to the exercise, you will see question number 3. It is asking a numerical type question. It's a problem solving question. Let us try to solve this question. The question says, what is the magnitude of the gravitational force between the earth and 1 kg object of this surface? Suppose you have earth and there is a mass 1 kg resting on the earth surface. So they are asking you what is the gravitational force between that mass and that of earth. Okay. So now mass of the earth is given to be how much? 6 into 10 to the power 24 kg. Mass of the earth is 6 into 10 to the power 24 kg, and mass of the object is 1 kg. And also it is supplied to us about the radius of the earth, 6.4 into 10 to the power 6 meter. That is, the radius of the earth from its center is, this radius r is 6.4 into 10 to the power 6 meter, right? Fine. So this is what we have right now. So how can you solve this question? You need to find out the gravitational force according to universal law of gravitation. F is equals to G m1 into m2, that means me into mo divided by r square, 6.4 into 10 to the power 6 whole square. This is G. G is gravitational constant and given by 6.67 into 10 to the power minus 11 into mass of the earth is given to you is 6 into 10 to the power 24 and mass of the object is 1. So if you calculate this one, it will be 6.4 into 6.4 into 10 to the power 12, right? So one thing let me teach you out here which is important, that how do you solve the powers? How do you solve the powers part? So first you take the number 6.67 into 6 and divide it by 6.64 into 6.4. Keep it as it is. Now just say it is minus 11 and 24. How much it will be? It will be 10 to the power 13 into 10 to the power 13. This 10 to the power 12 will go up. It will become 10 to the power minus 12. Right. So how much you will get now? Out here, whatever may be the number, that is 6.67 into 6 into 10 to the power 1 divided by 6.4 into 6.4. 6.4 into 6.4. Check. 10 to the power 1, 10 to the power 13 minus 10 to the power 12. First you solve the 10 powers, then you come to this. So the right answer for this question will be 9.8 Newton. Fine. So this is how we can solve this question. Now let us move to the next question. Now if you move to the next question, which is the problem solving, is question number 12, which says that gravitational force on the surface of the moon is only 1/6 as strong as gravitational force on the earth. 1 by 6 times. Okay. What is the weight in newtons of a 10 kg object on the moon and on the earth? Okay. Weight on earth will be mg. M is given 10 and g is saying in the question that you take 9.8 meter per second square. This is the constant gravitational acceleration due to gravity. So it will be 98 Newton, right? Now you need to calculate for the case of moon. So moon will be 1/6 times of the weight of the earth, that is 98. So 98 divided by 6. So it will be 1 and 38 is 6 times 16.3 Newton. So the weight in the moon will reduce if you go there, okay, than that of earth, right? Now let us move to the next question. If you see question number 13, it says that a ball is thrown vertically upward with a velocity of 49 meter per second. So its initial velocity u is given to be 49 meter per second. Fine. Okay. Calculate the maximum height the ball rises. The ball is thrown at particular height, it will move, yes or no? That height you have to calculate, means you have to calculate the distance, and also it is saying the total time taken by it in order to return to the surface of the earth. So how do you do this one? So we will use the equation of motion v square minus u square is equals to 2as. V is again the final velocity as soon as the ball reaches here is 0. So 0 square minus 49 square, 0 square is 0 only, is equals to 2 into acceleration due to gravity against the earth force. So it will be minus g. Minus g is how much? Minus 9.8 into s. So your s will come out to be minus 49 into 49 divided by 2 into 9.8. There is also minus sign attached to it. So minus minus get cancelled out. The right answer for this question is 122.5 meter. This is the right answer. Now if you want to calculate the time, that is the second part of the question. This is the first part, and the second part of the question, it is v is equals to u plus a t. Now v is 0, u is how much? Again 49, a we have seen that it is minus 9.8 into the time. So your time will be, t will be equals to 49 divided by 9.8. It will be 5 seconds. The time t is equals to 5 seconds. This is the right answer. Fine for this question. Now let us move to the next question, which is question number 14, which is saying that a stone is released from the top of the tower of height 19.6 meter. Height is given, suppose this is the tower, from there a stone is released and the height of the tower is given to be, it's there in the question, which is 19.6 meter. 19.6 meter. It is asking that calculates its final velocity just before touching the ground. So you have to calculate the final velocity, means v you have to calculate. So initial velocity will be how much? U will be equals to 0, right? Which formula you will use to calculate its final velocity? V square minus u square is equals to 2as. So v we need to calculate, u is 0 and 2 into acceleration is 9.8 and the distance covered will be height, that is 19.6. So v will be equal to root over of 2 into 9.8 into 19.6. So your final velocity v will be 19.6 meter per second. If you solve this one, solve the square root, this is the answer which is going to come. So now let us move to the next question, that is question number 15. Question number 15, it says that a stone is thrown vertically upward with an initial velocity of 40 meter per second. Initial velocity u is given to be 40 meter per second. Fine. Taking g equals to 10 meter per second square. G you have to take 10 meter per second square. And it is also asking, find the maximum height reached by the stone. Maximum height means if you throw from here till what height it will reach. That means you have to calculate the distance of the stone and also find out what is the net displacement and the total distance covered by the stone. Okay, first you find the maximum height reached by the stone. So this is what is supplied to us. We will be using the formula v square minus u square is equals to 2as, right? You need to calculate s. So s will be equals to v square minus u square divided by twice of a, and v is given to us, right? Final velocity will be 0 minus initial velocity is given 40, that is 40 square divided by 2 into 10. So, the right answer will be minus 40 into 40 divided by 20. So, what you will do is, here the acceleration will be minus because it is going against. So, out here it will be minus. So, minus and minus, it will cancel out, 20 into 2 times. The displacement covered by the body will be 80 meter. Sorry, the distance covered by the body will be 80 meter. Now, what will be the displacement covered by the body? It will move 80 meter and then again come another 80 meter. Final minus initial position, 80 minus 80. So, your displacement will be 80 minus of 80 meter, right. So, it will be 0 and your total distance will be 80 meter plus 80 meter. 80 plus 80 will be 160 meter. This is the total distance covered by the body.